Hi, good evening, everyone. Am I audible?
Hi, Nikhil. Good evening.
Hi,
Yes,
very
yes.
good evening, Nikhil. So welcome everyone. So we can, give the recap for yesterday's session for 5 minutes, and then we can continue the day one session. Meanwhile, more students are joining. Okay.
Yeah, sure.
Okay. Thank you.
So I'll quickly share my screen. So yesterday, the main topic or the main objective which we have discussed was the entire topics or the entire coverage areas. So this document was also shared amongst the students, and I hope you must have gone through the contents. Yesterday, we have discussed about certain examples like where all the lab activities will be, utilized, what kind of tools and what kind of techniques which we'll be using, how we'll be covering these labs, like we'll be using TriHackMe. Okay, so the entire course is divided into almost 10 phases, if I'm not wrong. Okay, this is in this document you can see only 9 phases, but we have a phase 0 also, which will be covering basics of networking, basics of Linux, so that you are comfortable with using Kali Linux and certain other operating system like Parrot OS, etc. And after the day phase 0 is over, we'll start with our phase 1, that is the fundamentals of cybersecurity, so that you are oriented towards a security domain of the entire course. Okay, so this is what we have discussed yesterday, and then we have discussed about the objectives of several students. What are they expecting in the course, and how this course is going to benefit them. Okay, so these were also discussed yesterday. So today, my plan is basically to commence with basics of networking. So I believe we have few people who are already in networking field. And is there anyone who is not so comfortable with networking? I can see Arya Joshi is a new student. Yesterday, I did not see Arya speaking. And is there anyone in the present set of participants who are not so comfortable with networking or who are already experienced in the networking field?
I have experience in networking, Nikhil,
Yeah,
since I worked on VoIP. Yeah.
VoIP, correct, correct. And Baki students. Okay, and nevertheless, so what I'm going to do is I'll just give a quick walkthrough with respect to the networking terms and terminologies and uh, the topics which we require in networking, so as to ensure your journey in cybersecurity is smooth. Okay, so Sachin, I'll start, or should we wait for some other joinees?
No, no, we can continue, sir.
Yeah, cool, cool. So the introduction to networking. Uh, I hope you are able to see my screen.
Yes, Nikhil.
Yeah, sure. Okay. Let me just connect my tab also. Yeah, cool. So introduction to networking. So the first, I'll try to make it uh, as much as interactive as possible. Okay. So I'll be asking several questions. I would require the students to unmute yourself and then give some, response, so that we can go ahead with the classes. Okay. So introduction to networking. The first fundamental question right now, which I'll be asking, is why do we need to know networking? Why should a ethical hacker or a red teamer should know networking? What could be the reason? Hmm? Okay, so basically, see, in any in any engagements, so for a red teamer or a ethical hacker, any assignment or any engagement to perform a ethical hacking activity or a red team engagement, we will be seeing or we'll be observing or we'll be targeting huge networks. Okay. The networks will consist of data centers. The network will consist of maybe OT systems, maybe IT systems. And in the IT systems, we'll have several servers, we'll have several clients. Now, all these entities are interconnected through a computer network. Okay, so with that, we'll just come to the first basic definition of a computer network. It's a group of computing systems. It allows us to communicate and share information. And then we'll be, then there is a simple model, OSI model, and a TCP IP model, which is a kind of a real world networking model, which are utilized to explain core concepts of networking. But here, as an attacker or as a defender, as an attacker or a defender, we should know the entire OSI model properly so as to identify what are the certain types of attacks. Okay, certain types of attacks as per the OSI standard. Now coming to Now, this is just a basic analogy, okay? It's like networks are basically simply connecting devices so that the data and the resources, everything can be shared. Now, this is what we are going to use in this slide. What is the perspective? Okay, the hacker perspective. So, for proper ethical hacking, you should have a complete core knowledge, or you should be completely thorough with how network works, how data or information packets are sent and received, and how you can utilize a network to gain access through maybe a remote code execution or maybe some other vulnerability, and then perform a better red team engagement. Okay, so in this slide, what I'll just explain is like networks are simply nodes which are connected using several protocols. So the basic necessity is like, let's say you have a system, you need to reach the system first. Okay, through the network. Say for example, you have a laptop. Okay, you have a laptop, you have never connected that to any network using your Wi-Fi or using a Cat6 cable, and you never connect a pen drive also, or you don't connect a CD also. Nothing is utilized in this laptop. Is there any way for this laptop to get hacked? Hmm?
No.
There's no way. Exactly. So that is the main requirement. So most of the systems are connected to some kind of network. Most of the systems. Okay, there are certain systems which are called, let's say, air gap. Okay, air gapped is a term which we generally use, which means that this system is never connected, or the network which has this particular system or a group of systems are air gapped from a different network. So all these concepts are basically to make you understand that as an attacker, how you can reach the system. Since 95% of your targets will be in a network, you should be thorough with networking concepts. Okay. Now in the networking, the data is sent as packets, and the frames and all these terminologies which we'll be discussing in OSI model. Okay, that is not so relevant for an attacker unless and until you are performing something called man in the middle attack. Okay, so coming to the next slide, which we'll be discussing a basic network hardware components. Okay, so like you have a system, to connect this system to any network, you should have a network interface card, which is generally found inside your motherboard. So we might use a Cat6 cable to connect this particular laptop or a system to a network. Okay. Now, in the network, what will be the first device to which our laptop or a client PC or a server will be connected out of this? Is it a gateway? Is it a switch? Is it a hub? Or is it a bridge? Which would be the device? See, I'm sure everybody is having basic networking knowledge. That's why I'm just skipping the explanation part of all these devices and directly go into the core requirement. Okay. So generally, a network is designed in such a way that, okay, I'll just make a new one. Okay. Yeah. Okay. So yeah, it's visible. So let's assume that we have certain set of systems. Okay, these are certain set of client PCs. Let's say this is a Windows PC, this is a Linux PC, this is a MacBook, and this is a again a Windows server. Okay, all these devices are part of a organization. Let's say organization A. Now this organization wants to perform a basic networking. How do I make sure all these devices are forming a network? Chandan or Priyanka, you can give me a response. Which device will be using to make sure all these devices can be made as a network, can be converted into a network? Right now, all are standalone. Nothing is interconnected.
Nikhil, I didn't get your question. What are you trying to say? I
Yeah,
mean, can
my
you
question.
repeat?
Yeah, my question is, it will be a switch. Correct. We will be using a network switch, or we can even use a network hub. Okay.
Okay.
So we just need to connect these devices either into a hub or a switch. Now, once this is connected, will it become a network?
Yes, it will
Directly, will
become
it
another.
become a
Yes, yes. If all the devices connected to through switch or hub, it will automatically become a network.
So, what about the IP address? How does this Windows system know how to communicate to the Linux system? So, mere connecting to the hub, after connecting, we need to do something, right?
No, if we are connecting to hub, then we have to connect at least one router.
Correct. So, you should have some other device to perform a action like assigning of IP address. Now, assume you don't have a router, you just have a hub. Or let's just assume you have a Windows system and you have a Linux system. Okay. You don't even have any other networking equipment. How do you make a communication link between these two?
By providing an IP address, private IP address.
Okay, private IP address. So first, I will be interconnecting these two devices using a single LAN cable or a single
Yes.
Cat6 cable. Okay. What is
Yeah.
this network called? What's the name of this network?
Local area network.
Local area network is a big term, but this type of connection, we have a specific name for this.
Uh,
So it's called peer to peer
Peer to
network.
peer. Yeah, yeah.
Okay. Peer to peer network. Now, this is one of the simplest network which we can prepare. Or let's assume you have a Windows host and you are running a virtual machine on top of that. Here also you can make such a network by just preparing a virtual router or a virtual switch in the VMware or in your virtual box. Okay, this we'll discuss later. Now we'll not come into this particular topic. Now here, what I am trying to show you is these are the devices which are generally found in the big networks. Okay, first is the switches. All the devices which are supposed to be connected, all the devices which are supposed to be made part of a network are connected to a network switch in general. Hubs are generally not used because these are not secure. Okay, this is not secure. So from the attacker perspective, okay, let's start thinking from the attacker perspective, why a hub is not secure or why the hub is beneficial for an attacker. Can somebody give me a response? Let's say we have an attacker. He identified one network is created using a hub, and that hub is having some, let's say, 8 ports. As of now, 4 ports are utilized. Okay. Now he has physical access to this hub. What is a benefit for the attacker? Anyone? What is a benefit for an attacker to in case if somebody is using a hub for forming a network? The slide has the answer actually.
In hub, usually the uh, ports, whatever is configured on one port is visible on all ports.
Correct.
I'm not.
One
I'm not sure if.
correct. So that is basically, see, hub you cannot configure first of all. Okay. You cannot configure. No configuration. And all the ports will broadcast to every other
Each other.
ports. Okay, the broadcast domain. So this is how I generally try to explain. Sorry.
Nikhil, your voice faded
Yeah,
away.
sorry. So this is how generally I try to explain the concept, like how this is going to benefit an attacker or how it is going to affect your security. Now in hub, what is going to happen is that, let me just, yeah. So in a hub, let's say you have these many ports. Okay. So 4 ports and sorry, yeah, 8 ports. So if you're connecting one port to a PC, second port or the last port to another PC, when this is trying to communicate to the PC1 is trying to communicate to the PC2, when the hub receives packets on port number 1, the hub is going to broadcast this packets to all the ports. And PC number 2, when it also receives the particular message, it accepts it and performs the acknowledgement or remaining activities. In hub, you will not be able to configure it. You will not be able to MAC bind it. No MAC binding. You will not be able to logically shut. Okay, these are the basic which we cannot do in your hub. So let's say an attacker has connected to this particular hub, and the attacker is trying to do something. So from our discussion, what can you understand? Like PC1 is trying to communicate to PC2. This is a packet, let's say packet P. Packet P is sent to all the ports. So PC2 also received the packet. PC2 sends a packet response back, that is R. So R is sent to all the ports again. and PC1 also receives R. So the communication is complete. Is it affecting the communication when the attacker is connected to the hub? Is it affecting the communication between PC1 and PC2?
No.
No. But is the attacker benefiting out of this kind of engagement?
Yes.
What is the benefit?
He has access to both the PCs.
No. That is where we are getting it wrong. Do
He's
like,
getting packets.
he is getting
Packet.
packets. May I know who's it? Arya.
Huh.
Yeah, Arya. Correct. So he is getting both the packet P and packet R. That does not mean he has access to this particular PC1 or access to this PC2. No, he does not have the access. But what he will get to know, he is able to monitor what PC1 is talking to PC2 and what PC2 is talking to PC1. So this is a example for MITM, that is man in the middle attack. Okay, so we'll be explaining each type of attack one by one, but this is generally how introduce several kinds of attacks. From the core concepts itself, I'll be trying to introduce you to the attacks also, so that you will get to know, yes, if I leave my hub or if I leave my switch unconfigured, that's going to cost me. Now, for example, this hub is actually a switch. Just assume this is a switch. Okay. And in the switch, you have proper broadcast domains and proper communication protocols. So in a switch compared to a hub, will there be any broadcast of packets from port number 1 to all the other ports when PC1 is communicating to PC2?
No.
No. But here what is going to happen is, let's say if the physical access to the switch is available. Okay, let's take a new diagram. Okay, you have a switch, you have a PC number 1 and PC number 2. Generally, in almost all the organizations, the other ports which are not utilized are logically shut. So that even if somebody tries to connect to this particular port, he will not be getting a network connection or he will not be getting any response. That will be logically and you can even physically shut it. Okay, so this is the benefit of using a switch. Like you can configure it in such a way that you can bind and you can MAC binding is a different term. Like PC1 is bound to this particular port using the MAC address. Okay, now let's come to what is MAC address. So you have a PC, you have a NIC card, which we have just discussed here. The first device, which is a NIC card, which allows a computer to connect and communicate within the network. So every NIC card will have a specific address called MAC address. Okay, so this MAC address will be always unique. This will have a what do we say? This is going to have a OEM information also. Like if you get a MAC address, you will be able to find whether this MAC address belongs to HP or Cisco or D-Link or any device. You will be able to identify the MAC address just using your information. So have you ever tried doing this? Anyone? Any student? By finding your MAC address and seeing what device it is? Anyone?
No.
No. So let's just do that. So I have my command prompt. So the simple command which I am going to try is get MAC. So you can see the MAC address of my device, correct? It is this, and I'll try to use, yeah. So MAC address find or lookup. So this website, okay. So this website will allow you to just see exactly the MAC address or what device this MAC address is. So it will try to map it to the vendor. You can see the vendor details. Okay, so let me just do a search. So it's going to give me the vendor details. Yeah, cloud network. I'm using actually a HP laptop. So probably this HP laptop has a Chinese NIC card. See, this NIC card has been prepared by Cloud Network Technology Singapore. Yeah, Singapore probably. So this is not directly mapping it to my HP device, but you can also perform the same check to identify to which device or to which vendor your MAC address belong to. Okay. Now that is just one example. Now every device has its own MAC address. Using the MAC address, you will be communicating in the network. Now switch communicates using your MAC addresses. A router communicates using what? If switch uses MAC address, what does the router use to communicate?
IP.
Correct, IP address. Now, IP address is it's like a phone number, you can say. Okay, if you want to reach someone, you need to know the device's IP address. Or if you need to communicate with any device, you need to properly have a IP address of that. Now, IP address is also divided into two, like public and private, which we'll be discussing in the later segments. Now, here in the networking, we will be more focusing on switches and routers. Now, switch is basically a layer 2 device. Yeah. Switch is basically a L2 device and router is a L3 device. It's basically your OSI layers, which I'm discussing. Now coming to types of networks, LAN, WAN, and MAN. Most of the engagements will be limited to given access to their network, and from the network you will be asked to laterally or horizontally move. Okay, that is one. Then WLAN is basically your wireless LAN. Instead of using a switch, a traditional switch and traditional router, you can directly have wireless gateways so that all your devices can be communicating through Wi-Fi protocols. Network topologies. Now, this is more from a perspective of a CompTIA Network Plus or from a CCNA perspective. We will not be directly requiring all these topology related information, but still just for the information, you have bus, ring, tree, star, mesh, and hybrid. Most of the times, our core routers will be in the mesh topology. Most of the times, our other devices will be in a star topology. Star is basically like you have a network switch and then you have all the devices connected to the switch. And let's say if you want to extend the network, you just take a link to another network switch, and then from there also you perform this. And in case if you want to connect it to another network altogether, you will be connecting this segment to a network router from which you will be able to communicate outside the network. Now we'll be discussing this one by one. Now these are the examples of topology which we don't require. Now, yeah, OSI layer. So everyone comfortable with the layers of OSI model? Is there anyone who wants a basic recap of what a OSI model is? Participants? Yeah, I can see a thumbs up from VJNT. Other students? Okay, so basically it's a simple model prepared by ISO. Okay, so it's called ISO OSI standard. So in the OSI model, yeah, Shahid. Okay, you just responded yes. Okay, proper. So in OSI model, your networks can be segmented, or your networks can be divided, or your networks can be classified into several parts, and to help you, or to help the person to identify the problems, or to identify the issues, or to for proper configuration, we are using this particular OSI model. Okay, now physical layer is the first layer where the exact exact communication happens. Okay, so examples of physical layer is like your air, which is used by your wireless, okay, Wi-Fi, uh, cables, basically your Cat6 cables, which are utilized in normal networks. So these are your physical medium, and then we have OFC cables, which are used for long range communication. Okay. Then once the uh, first layer is over, we have the data link layer. So let's design a small network also here. Okay. We have one small laptop. We have another laptop. This laptop is in Bangalore and this laptop is in Mumbai. And I am part of an organization called ABC. I want to make sure there is a communication between this laptop 1 and laptop 2, which are present in two different cities. Okay. So what I generally do, what I should be doing is I should connect this to internet, right? So generally what we do is we will connect this to a Wi-Fi, or maybe to a network switch, which provides you the internet connection through a ISP provider. What is ISP? Internet service provider. Okay. I the router connects you to the internet. So this internet, and from here also we have again another router, which is your last edge router of the ISP, and then maybe a switch, and then the laptop or the device at Mumbai. So here, what are the physical layers which you can identify, students? Priyanka, Arya,
Can
Shahid,
you repeat, sir, question?
VJNT. May I know your name, please?
Yeah, my name is Venkat, sir.
Venkat. Hi, Venkat.
Yeah.
Yeah. So we did not have your introduction, so we'll take the introduction later. So can you give me what are the physical layer devices which you can see in this particular simple network diagram?
Yeah.
Switch,
Sorry, Arya?
switch and routers.
Switch and router are actually part of other layers. Now we are just discussing what the physical layer. Okay. So the answer is here
And
only. You
network
can see the cables. The answer is here itself. It's the cables. Okay. So all these cables, the cable over here, the cable over here, and the cable over here, everything is part of your physical layer. The data link layer has the network switches. Okay. So all these network switches are part of L2. That is why I explained L2 for network switch and L3 for network router. You must have seen this, right? L2 for a switch, L3 for a router. Now, these terms you should have throughout the course. You should be remembering this throughout the course, because these are the basic core concept from the networking which we require. Okay, so the data link layer consists of your network switches, and the network layer consists of your routers. Clear? Okay, so this is your L3 device. This is also your L3 device. Coming to transport and above, you will not be able to completely or directly associate it with a physical device. Okay. So there are firewalls which can work on layer 4 to layer 7. We'll be explaining that later. But in proper traditional networking, whatever devices which we have, they work on layer 1 to layer 3. So is this concept clear?
Yes.
Okay. Now, this presentation is basically from my complete networking class, which explains each and every layer, and which is going to explain you how the data frame or how the data is going to move. But instead, I'm just directly coming to the same network diagram, similar to which I have created or I have drawn in front of you. So here you can see this PC wants to communicate to this web server. Okay. How the activity happens. Now from the PC, the packets travel from all the layers to the physical layer, like application layer. For first example, I'll connect each layer with one example. Okay, assume this web server is hosting a internal mail server. Okay, internal, let's say Outlook web application, OWA. Okay, let's assume that Outlook web application is hosted by this web server. This Outlook web application can be accessed using what software from your PC?
Outlook.
Outlook, yes, that is one application, but I'm talking about OWA, that is Outlook web application. So we'll be generally using a browser for that, right? You have Outlook application also installed in your Windows system. Okay, that also is an example. So either Outlook or a web browser like your Mozilla Firefox or Internet Explorer or maybe Google Chrome, etc. So all these different browsers or any application which is acting or which is directly giving access to a user falls me as a user. I am dealing with this application layer in my PC. Okay. So in the application layer, I give my username and password. So that is sent or that is converted into several packets or several data frames, etc., and which will start traveling down all the way till physical layer. So application, presentation, and session. These three are kind of your which is present inside your Outlook itself or in your browser itself. And then transport layer is from your operating system. So in your OS, there is something called process and there is something called port. Are you familiar with this two terms, process and port? So every system or every computer will be running several processes. Okay. Your Outlook will run as a process. Your browser will run as a process. Your antivirus runs as a process. Your task manager also runs as a process. So you will be able to see all your running processes in your Windows system using Task Manager. Have you ever checked your running processes in Task Manager?
Yes.
Yes. So in that you will have something called process ID. It's called PID. So every process will have something called port associated to it in case if it requires network. Like Outlook will have a certain port. So port is a logical number which can start all the way from 1 to 65,535. And here 1 to 1024 is generally reserved. These are reserved, and from 1025 to 65,535, randomly the operating system assigns for the process. Okay, now this will be required for assessing the attacks. This will be required for you to identify certain process or certain what do we say, certain malware. In case if you prepare a malware or if you want to perform a malware analysis or a malware assessment, you will require the uh, details of process and ports. Okay, so let's come to the OSI model. So here, yeah, so here from the transport layer, sorry, yeah. So from the from the transport layer, every process will get a port number. Okay, let's assume your Outlook has got a port number 8000. Okay, the Outlook process which is running in your PC. Okay, so this is the network connection. So this is the network connection. But here internally, all these activities are happening inside your client PC. And once it reaches the switch, it is in the network layer. And from the network layer, it goes to your data link. And so basically your switch is, sorry, my mistake. Switch is supposed to be in, switch is in data link layer. So from here, your network layer of your PC, that is your maybe network interface card. Yeah, correct. So your network interface card communicates with your physical layer. That is your, let's say, what will be the physical layer? Probably your Cat6 cable. So you have your Cat6 cable here, which is connecting to your switch. So this connection is your physical layer, and the connected device, your switch, that is your data link layer. Okay, let me change the color of my thing. Yeah. So this is your data link layer. And from here also, the packets travel to your router because this is part of a different network. So here we are not discussing about your IP addresses, but instead, what I will say is this particular network is of, sorry, yeah, this is part of network segment A, and this is part of network segment B. It requires a router, which is your L3 device. So that is why you can see In the router, you have a network layer. In the switch, you don't have the network layer, or it has only the physical layer. So the physical layer has your Cat6 cable coming and connecting to your port. This is a physical port, not the port which we have discussed in the transport layer side. So the packets are connected to, the packets are reaching your switch, and then from the switch, from let's say from this port to the other port, it travels without doing any broadcast. It reaches over here, and then from here, it reaches your router. And from the router, it is again sent to all these layers back to the switch of your second network segment. And then from here, again, it will reach all the way till your web server. Now here in web server, let's just assume Outlook application is running as a process. So the process ID will be, let's say, process ID 653, and it will be given a port number also. So the port number will be present in which layer? Students, in which layer we'll have the port number in the web server side?
Transport layer.
Correct, transport layer. So in the transport layer, we'll have a port number. In the network layer, we'll have an IP address. In the data link layer, we have a MAC address. Same goes to your client side also. Your network layer will have your IP address of your client PC. Your data link layer will have your MAC address of your client PC. And then physical layer, you have your normal Cat6 cable. Okay, now a simple question. Does the PC know the IP address of your web server?
I guess no.
Uh, okay, I'll ask you a question. You are configuring a IP switch. Sorry, you're configuring a IP phone. Okay.
Mm-hmm.
Do you get to know the IP address of your CUCM server?
From the phone?
Yeah.
No.
But do you get to know the IP address of your IP phones from the CUCM server?
Yes.
Yes. So just assume this PC is a IP phone, and
Okay.
when
Your voice is breaking, Nikhil.
network, you need to know the IP address. Okay. You need to know the IP address to communicate anywhere in the network. Without that, you will not be able to perform any type of communication.
Uh,
Yeah, tell
do
me.
it have
Arya?
public IP or private IP?
Public and private. So here we are not deciding, or here we are not talking about any, what do we say? I've just told this is a segment and this is another segment. I did not tell that we are segmenting or we have a network address translation over here.
Okay.
Okay. Okay, so NAT, yes, perfectly correct. You will not be able to get the exact IP address of the other side, but we'll be discussing that later. But here in a normal network, okay, like a normal organization, which has a FTP server, or which has a mail server, or which has a file server, all your client PCs will be able to get the IP address of your servers,
Yes.
which are required for communication. Okay. But so that is one question which I wanted to ask. Second question is, do the PC here get to know the MAC address of this web server in this network diagram?
No.
No. Why?
Because it doesn't require MAC address to connect with the web server network.
It does not require, correct. But since the packets are going all the way from your level 3 to level 2, always level 2 is coming in the game, right? Everywhere you
Yes.
can see level 2 is coming in the game. So, is there a chance for your PC in the left side getting to know the MAC address of your web server? Or what stops sharing this MAC address with this particular PC
Firewall?
in this network?
Okay.
It's actually your router.
Now,
Okay, so what happens is the communication. So your answer is correct only. The communication requires a MAC address for only this segment. So here, when we are trying to communicate, the MAC, it will be the packets will be sent to the MAC address of this router. The packets will have the IP address, destination IP address of the web server, but till here, let me change the color. Yeah. So when the packets are sent from here till here, the IP address of the web server will be present in your packets, but the MAC address will be, or the destination MAC address will be of the router. And once the packet is received at the router, the MAC address will get changed from this area. The MAC address will get changed from this area, but the IP address, the destination IP address will remain the same. The destination MAC address will get changed from here to the web server MAC address. So you can actually perform a simple exercise as and when time permits or as and when it's possible. You can just try running ARP minus A command in your terminal wherever you're connected. You will be able to get the MAC address of all the devices which are present in your network switch or your Wi-Fi gateway if you're communicating with any of the device. Okay. But you will not be able to get a MAC address of any device after the router. Okay. So this is from the normal networking standard. But just assume that this web server is a SIEM server. Are you familiar with the topic SIEM, students? Is there anyone who is not familiar? You can just tell me
Not me,
so that
Nikhil.
we. Okay, okay, no problem. So we'll not discuss that example because it requires me to explain what is SIEM. We'll be covering in our later sessions. Okay, so here
Okay.
what I'm trying to show you is in a normal networking standard, the MAC address will get cut inside your or MAC address will get stopped the moment the packets or the moment you reach a L3 segment or a L3 device. After this, your MAC address will never travel or the information with respect to your MAC address will never go to the second segment. Okay, so now coming to the TCP IP. So it is basically your exact same OSI model, but it is just combining few layers. Okay, your physical layer and data link layer is combined into network interface layer. That is your normal NIC card, Wi-Fi cards, etc. Network layer remains as same network layer. Transport layer also remains as the same transport layer. All these session, application and presentation, these are also combined into your application layer. Okay, so that is the reason when I started talking about Outlook, I told all these three. You must have seen this, right? All these three are used for your Outlook or your web browser. So, for example, Telnet, SSH, FTP. Now, in this, and that throughout the session, we will be requiring knowledge about SSH, Telnet, FTP, then DHCP, yes, HTTPS. No, we will not require much knowledge about HTTP and HTTPS because we'll not be discussing about the protocol. But these four which I have marked, you will require the knowledge which we'll be covering tomorrow. And from the transport layer, we just need to know what is the difference between TCP and UDP. Okay, which is again not so required in your ethical hacking or in your red team engagement exercises. But we'll be explaining you several types of tools which perform TCP scan and UDP scan. Your internet layer or this particular layer where we'll be using your IP and ICMP. We'll be discussing ARP also will be discussing because several attacks are also available in this particular internet layer. And network interface card layer is basically your layer where your device gets connected. Like you have a laptop has a NIC card. So NIC card is basically your network interface layer. Okay, so yeah, so basically MAC address and IP address. So this is different. Okay. So this is what I have planned for today. Just a basic of networking. Uh, does anyone require class on how to configure IP address? Like what is a IPv4 address? How the IPv4 address is designed? How to identify a network part and host part? How do you perform subnetting? How do you perform gateway assignment? So do you guys require the explanation on these part? Because this requires at least half an hour to 45 perform this, and we'll be able to go ahead. Otherwise, we can go ahead with normal, yeah, from here, the public and the private IP address, NATing, gateway. If any of, if even at least one student requires it, we'll be covering that. No worries on that.
Yes, Nikhil, little brush up kind of thing should do.
Yeah, brush up. So definitely we'll be doing a brush up of IPv4 networking so that when we design a small network, how we can design a small network. So that will be explained tomorrow proper. So till here, is there any doubt from the OSI concepts and from the TCP IP concept? From the attack point of view, okay, from the normal basic knowledge point of view. I'm not discussing on what kind of frames will be sent, etc., etc. Is there any doubt till here? Any student? No. Please feel free to ask, okay? Please unmute and you can ask or you can just type. Any doubts? All good.
Yes, guys, you can ask finally. Else, we are summing up today, sir, right?
Yeah, we are summing it up.
Yeah, okay, sir. So, yes, you can, finish up.
Okay, so what I will do is I'll just share this presentation also. Okay, I'll share the entire presentation. So tomorrow's session also it will be easy for everyone to just go through the content and be prepared. So let me close it. Don't save. Yeah. Introduction to networking in the chat. I'm going to paste it. So okay, so basically today what we have discussed is like what kind of information or what kind of knowledge you or a student requires from the networking domain, we have started by discussing a few networking devices, not all the networking devices, but a very few networking devices which we'll be encountering in in our journey. And we have discussed about what are the benefits of a switch compared to a hub. And then we have discussed about the ISO OSI layer. We did not discuss how the exact layers are, how the kind of packets will be, how the kind of data will be, but it is available in the presentation. You can all go through the presentation. What we have discussed was how the data travels from one PC to another PC or one PC to another server through the entire OSI layer concept. And then we have discussed about the TCP IP model, how the OSI layers are mapped to the TCP IP model. And then finally, we just discussed about what we are going to cover tomorrow. Okay, so the presentation is available for everyone in the meeting chat. I would request everyone to download and keep it so that you can also go through the content. And there are slides which I have not covered, but you please feel free to go through that. In case if there is any doubt, please ask in the next class starting itself, so that we can discuss that. Okay. So Sachin, I'm good from my side. Any students or anything, any questions, we can do that. Otherwise, we can wind it up.
Yes, yes, sir. Fine. It's fine from my side as well. We can close the session today, and tomorrow we can continue with the regular day to class.
Okay. Sure. So students, thank you. Thanks for the time.
Yes, yes, guys. Thank you for the time today. Good night, everyone who have not taken enrollment. They can connect with the admission team so that we can give the access and they can, like go through the content before coming to the tomorrow's class. Yeah. Thank you, everyone.
Thanks, Nikhil. Thanks, Sachin.
Good night, everyone. Thank you.
Good
Thank
night. Good
you.
night.